Dear students of class 9, welcome to you all in online class. I am Sudipan Bhattacharya. Today we are going to discuss about infinite series. This is lecture 2. I hope that you all have participated in lecture 1. If you don't, then go to lecture 1 and see the video, then come to the lecture 2. Today we are going to discuss about series. After this class, we will define a series, explain the arithmetic and geometric series, explain the partial sum of a series. We will be able to explain geometric series and arithmetic series. We will be able to calculate the general term of arithmetic series and geometric series. We will be able to determine the partial sum of arithmetic and geometric series. A series is simply the sum of the terms of a sequence. If finite number of terms are taken for a series, then it is called finite series. If number of terms is infinite, then we call it an infinite series. For example, 1 by 2n is a sequence which may be written as 1 by 2 or 1 by 4, then 1 by 6, 1 by 8, 1 by 10, dot 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 1 by 2n and so on. So from this series, this sequence, we can generate a finite series like 1 by 2 plus 1 by 4 plus 1 by 6 plus 1 by 8 plus dot dot dot. At last we will write 1 by 1000. Since the series is terminated after a finite number of terms, therefore this series is a finite series. And if we take series like 1 by 2 plus 1 by 4 plus 1 by 6 plus 1 by 8 plus dot 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 and so on, then the series is called infinite series because it is not terminated anywhere after uh, starting from 1 by 2. So the series which terminates at some point is called finite series, and the series which does not terminate after some point is called infinite series. Arithmetic series. If in a series difference between two successive terms is constant, then the series is called arithmetic series. Like 2 plus 4 plus 6 plus 8 plus dot 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 is an arithmetic series. But 2 plus 8 plus 16 plus 32 is not an arithmetic series because in first one we can see the difference between 4 and 2 is 2, and difference between 6 and 4 is 2, difference between 8 and 6 is 2. But in the second one we can see difference between 8 and 2 is 6, difference between 16 and 8 is 8, difference between 32 and 16 is 16. Therefore the second series is not an arithmetic series. If the first term is a and common difference is d, then an arithmetic series will be like this. First term, therefore it will be a, and at the second term it will be a plus d, and at the third term it will be a plus 2d, because in every term it will be increased by d. Therefore the first term is a and second term is a plus d, third term is a plus twice d, and fourth term is a plus thrice d, like this. You can compare this series with the first series we have given as example, like 2 plus 4 plus 6 plus 8. At the first example we can say first term is 2, and then at second term 2 plus 2, and third term 2 plus 2 plus 2, like this. So now we can say that after n terms, what we will get is a plus n minus 1 into d plus dot dot dot. How can we assure that this term will occur after when the term number is n? Because look at the first term, there is no d. Look at the second term, there is only one d. Look at the third term, there is 2d. Look at the fourth term, there is 3d. Therefore, in every term, uh, it is it has one less d. Like at the first term there is no d, at the second term there is only one d, 2 minus 1, term number minus 1 d, and the third term a plus term number 3 minus 1 equal to 2. Therefore at third term we get a plus 2d. At the fourth term, term number is 4 and 4 minus 1 is equal to 3. Therefore we get a plus 3d. So by this sequence, or by the concept of sequence, we can say up at the nth term we will get a plus nth term, therefore term number minus 1 into d, therefore a plus n minus 1 into d. So we can say that general term of any arithmetic series is un equal to a plus n minus 1 into d. Look here, in previous class we have used function of n, but in this class we are using un. So why we are using un? Because um, I wanted to confirm you that this is a kind of function, or I wanted to make you understand that un is a kind of function of n. Therefore we have used un. If you want to find out the third term, then you will write u3 and you will get a plus 3 minus 1 into d, therefore a plus 2d. If you want to find out the fourth term, you will write u4, which is equal to a plus 4 minus 1 into d, that is a plus 3d. Unlike this, here a is equal to the first term and d is equal to the common difference. You have to memorize this formula, and by memorizing it you will be able to answer a number of problems which are in your textbook. Geometric series. If a series is such that the ratio of two successive terms are always equal, then the series is called geometric series. In arithmetic series, we have seen that the difference between two consecutive terms are constant, and in the geometric series we can see that the ratio between two consecutive terms are constant or equal. Look at the series given 1 by 2 plus 1 by 4 plus 1 by 16 plus 1 by 256 plus dot dot dot. This is not a geometric series because the ratio between 1 by 2 plus 1 by and 1 by 4, or the ratio between 1 by 4 and 1 by 2 is half, but the ratio between 1 by 16 and 1 by 4 is 1 by 4. The ratio are not same here. If you divide 1 by 4 by 1 by 2, then you will get half. If you divide 1 by 16 by 1 by 4, you will get 1 by 4. So we can see that the ratio between two consecutive terms are not equal. Therefore, it is not a geometric series. At the second example, we can see that 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus dot dot dot. This is a geometric series, and it is also an infinite geometric series. This is geometric series because you can get the second term by multiplying half with the previous term. Therefore, 1 by 2 into half, or 1 by 2 into 1 by 2 equal to 1 by 4. Again, you can to get the third term, you have to multiply half with the second one. Therefore, 1 by 4 into half equal to 1 by 8. Again, to get the fourth term, you have to multiply half with the third term, that is 1 by 8 into 1 by 2 equal to 1 by 16, and so on. Every time to get the next one, we have to multiply a number with the previous one. This is the criteria of geometric series. Look at the previous one. We cannot multiply a single number with the previous one to get the second one. Like if we want to get 1 by 4, we have to multiply half with half. But if we want to get 1 by 16, then we have to multiply 1 by 4 with 1 by 4. Therefore, we can see that the same number is not multiplied to get the next term. Therefore, the first one is not a geometric series, and the second example is an example of geometric series. And since the series are not terminated here, they can be also called infinite series. A geometric series having infinite terms is called infinite geometric series. Now, what is the general term of geometric series? Okay, let us say or assume that the first term of a geometric series is A and the common difference of a geometric series is R. Then the series is as follows. The series will be A, as the ratio at the common ratio is R, we have to multiply A with R to get the second term, that is A, and second term is AR, and multiplying AR by another R, we will get AR square. Multiply AR square with the common ratio R, we will get AR cube, and so on. So we can see that the first term is A, and the second term is AR, third term is AR square, fourth term is AR cube plus dot 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 plus AR to the power n minus 1 plus dot dot dot. Why nth term is AR to the power n minus 1? Because in first term we have no R. Term number is 1 and number of R is 0. At the second term, term number is 2, but number of R is 1. At the third term, term number is 3 and number of R is 2. At the fourth term, the term number is 4 and number of R is 3. Therefore, at the nth term, term number will be n and number of R will be less than 1 less than n, that is n AR to the power n minus 1. So we can say that the general term or the nth term of a geometric series is as follows: un equal to AR to the power n minus 1, where the first term is A and the common ratio is R. Now we are going to discuss about partial sum or finite sum of an arithmetic series or an and geometric series. If from any series sum is taken up to first n terms, where n is a finite natural number, then the sum is called partial sum. Sum of first n terms is denoted by Sm. For instance, sum of first 3 terms is as 3. Sum of first 4 term is as 4, like this. So for arithmetic series, we have a formula that sum of first n terms Sn equal to n by 2 into twice a plus n minus 1 into d, where a is the first term and d is the common difference. We have to memorize this formula to solve mathematical problems. For geometric series also, we can develop a formula of sum of first n terms, which is Sn equal to a into r to the power n minus 1 divided by r minus 1, where r is greater than 1, and Sn equal to a into 1 minus r to the power n divided by 1 minus r when r is less than 1. So for geometry series, there are two formula to find out the partial sum, which is Sn, and Sn is equal to a into r to the power n minus 1 divided by r minus 1 when r is greater than 1, and when r is less than 1, you will get Sn equal to a into 1 minus r to the power n divided by 1 minus r. We all know what does it mean by a and what does it mean by r. A is first term and r is the common ratio. The proof will be shown in your general math class, so I will skip it here, but we need to know the formula to solve the problem in Hermaths. So example 1, we are given a series like 1 plus 3 by 2 plus 2 plus 5 by 2 plus 3 plus dot dot dot, which is a series. Now we have to find out the general term of the series and a formula for partial sum of the series. Using the formula, we have to find out the 100th term and find out the sum of first 79 terms. So first we have to check whether the series is arithmetic or geometric. Now we can see that if we want to get 3 by 2, we have to multiply 1 with 3 by 2. But if we multiply 3 by 2 with 3 by 2, we do not get 2. So we don't have, we can say that this is not a geometric series. So now we will check whether it is arithmetic series or not. So the difference between first two terms is 3 by 2 minus 1 equal to half. The difference between second and third terms is 2 minus 3 by 2 is equal to half, and same is for each couple of successive terms. So given sequence is arithmetic series, and the first term a is equal to 1, the common difference d is equal to half. Now nth term un equal to a plus n minus 1 into d, which is equal to 1 plus n minus 1 into half. Here we have put the values of a and d, and we will get by calculation that the final result is n plus 1 by 2. So we can say that un equal to n plus 1 by 2. Look at here, we have used the formula of general term or nth term of arithmetic series, which is un equal to a plus n minus 1 into d. If you don't know the formula, you cannot generate this formula you cannot calculate this math easily. You can do it, but it will be very difficult for you. Now we will apply the formula partial sum of arithmetic series, which is Sn, sum of first n terms Sn equal to n by 2 into twice a plus n minus 1 into d, which is equal to n by 2 into 2 into 1 plus n minus 1 into half, and by calculation we will get n into n plus 3 divided by 4. Now we have to calculate the 100th term. So we know that un equal to n plus 1 by 2. We have generated a formula for this series that nth term will be n plus 1 by 2. So for 100th term we will get u100 equal to 100 plus 1 by 2, that is 101 by 2. Look at here, we have used the un as a function. We have put the value of n in both sides. At left side we have got u100, and at the right side we have got the 100 term, that is 100 plus 1 by 2 equal to 101 by 2. And also to find out the sum of first 79 terms, that is partial sum up to 79 terms, we have to use the formula of Sn, which we have generated in our previous slide, that is Sn equal to n into n plus 3 divided by 4. So S79 equal to 79 into 79 plus 3 divided by 4, which is 3239 divided by 2. Uh, Now example 2, we are given a series like 1 by 2 plus 1 by 4 plus 1 by 8 and so on. We have to find out the general term of the series and the formula for partial sum of the series. Using formula, we have to find out the 10th term and find out the sum of first 9 terms. So we can see that each term is got by multiplying half with the previous one, that is 1 by 2. If you multiply half, then you will get 1 by 4, and if you multiply half, then you will get 1 by 8. So the progression is by multiplying a constant number with the previous term. Therefore we can say this series is a geometric series. So the solution will be like this. The ratio of first two terms is 1 by 4 divided by half equal to 1 by 4 into 2 by 1 equal to half. You can see that we have divided the second term by the first term. To get the difference, common difference or difference between two terms, you have to take the second term minus the first term, the third term minus the second term. And for the ratio, you have to take the second term divided the first term, or the third term divided by the second term, like n plus 1th term minus nth term, or n plus 1th term divided by nth term, like this. And so for calculating the ratio between the first two terms, we will put 1 by 4 divided by 1 by 2, and by calculation we will get 1 by 2. The ratio of third and second term is 1 by 8 divided by 1 by 4, which is 1 by 8 into 4 by 1 equal to half, and so on. So we can say in this series the ratio between two successive terms are constant. So we can say that the series is a geometric series, and first element is half and common ratio is half. So the general term, the formula of general term of geometric series is un equal to a r to the power n minus 1, as we have learned before. And if we put the values of a and r, we will get half into half to the power n minus 1. We will get half into half to the power n into half to the power minus 1, and half to the power minus is cancelled and it will be 1, and so it will be 1 by 2 to the power n. Since r is less than 1, the sum of the first n term is Sn equal to a into 1 minus r to the power n divided by 1 minus r. If we put the values of r, we will get half into 1 minus half to the power n divided by 1 minus half. So as the denominator 1 minus half will be equal to half. So in the denominator we will get half, and in the numerator we will get half into 1 minus half to the power n. Now the half of the denominator and half of the numerator will be cancelled. We will get 1 minus half to the power n. So now we are going to calculate the 10th term of the series, that is u10. u10 equal to half to the power 10, that is 1 by 1024. Since un equal to half to the power n we have calculated previously, we got this u10 equal to half to the power 10, putting the value of n. And sum of first 9 terms, that is partial sum of first 9 terms, is s9, which is equal to 1 minus half to the power 9. As we calculated that Sn equal to 1 minus half to the power n, so S9 equal to 1 minus half to the power 9, which is equal to 1 minus 1 by 5, 1, 2, and calculating this we will get 511 divided by 512. So this was the solution of these two questions regarding partial sum and general term. Now you have some homework to do about these kind of problems. Uh, you have to calculate the nth term and the sum of first n terms for the following series, and also calculate u10 and s10 using the formula, that is 10th term and sum of uh, first 10 terms using the formula you generate for each series. Now your series are like this. I will not read it out. Please write down in your text. Uh, you may find out some problem to solve this kind of this uh, homework. If you don't um, if you cannot solve some problem, some series, then find out why this series is not solvable by using the formula you have got in this class. So mathematics is not about numbers, equations, computations or algorithms. It is about understanding. William Paul Thurston. Thank you everybody. See you in the next class.